So this is National 4 and National 5 Chemistry, and we are looking at Unit 2, and we're still looking at different homologous series and hydrocarbons. This time we're going to finish with cycloalkanes as one of our homologous series, and we're going to introduce you to some of the more technical terms used to describe hydrocarbons. So cycloalkanes is another example of a homologous series. And these are hydrocarbons that actually form a sort of circle of sorts. Now the smallest number of carbons needed to form a cycloalkane is 3, which means that the first member of the cycloalkanes is cyclopropane. Then we have cyclobutane, cyclopentane, etc. So the only thing when it comes to naming these is you look at the number of carbons in the ring and you use the appropriate prefix. So if there's 3 carbons, it's prop. If it's 4, it's but. And you give it the name like it is an alkane, and all you do is add cyclo in front of it. So the examples that you need to know are cyclopropane, C3H6, cyclobutane, C4H8, cyclopentane, C5H10, cyclohexane, C6H12, cycloheptane, C7H14, and cyclooctane, C8H16. Now, cycloalkanes have the same general formula as alkanes. So that is CnH2n. So however many carbons there are in a cycloalkane, there is 2 times as many hydrogens. Cycloalkanes, just like alkanes and alkenes, can be used as fuels and can be used as solvents. So what we're going to move on to next is just looking at some of the chemistry and some of the words specifically used to describe all types of hydrocarbon. So the first thing we need to know about hydrocarbons is that they are insoluble in water. Alkanes, alkenes, and cycloalkanes are insoluble in water, which means that they do not dissolve. So oil is a hydrocarbon, and you know that if you mix oil and water that they form different layers. That's what happens if you try and dissolve an alkane, alkene, or cycloalkane in water. It doesn't dissolve, it forms layers instead. Now the next term that we need to know is saturated and unsaturated. Cycloalkanes and alkanes are described as being saturated molecules, and that is because they only contain carbon-to-carbon single bonds. So the only bonds that exist between 2 carbon atoms is a single bond, and we describe that as being saturated. On the other hand, if you contain even just 1 double bond between 2 carbon atoms, you are described as being unsaturated. And so alkanes are an example of unsaturated molecules as they contain carbon-to-carbon double bonds. Now, if you have lots of double bonds in a structure, you would be called polyunsaturated. And polyunsaturated is a word often used to describe things like margarines. And that just means that that margarine is made of molecules that contain lots of these double bonds in them. Now, this is a way to remember saturated and unsaturated. If you are saturated, that can mean that you are soaked through and wet. And you're more likely to get wet outside when it's raining if you have a single layer on in the pouring rain. So if you're wearing a single layer, that's like having a single bond, and you're likely to get saturated with rain. Unsaturated can mean dry. And if you're going to be dry, you need to have a double layer on in the room. So a double layer, like a double bond, makes you unsaturated. That might help you remember. However, I think it's easier to remember single bonds, saturated, and it means if you double bond, you're unsaturated. So saturated and single both begin with S. And the next word that is sometimes used to describe hydrocarbons is isomers. Now, isomers are compounds with the same molecular formula but different structural formula. So isomers may belong to different homologous series and will usually have different physical properties. So they have the same molecular formula but a different structural formula. That is the definition of isomers. And what you probably have noticed is that alkenes and cycloalkanes are going to be isomers of one another because they have the same general formula. But another way in which we can have isomers is a branched compound where the branch is just on a different carbon. So for example, if we have a methyl group on pentane, we could have 2-methylpentane or 3-methylpentane, and those would be isomers because they would have the same formula, but they would have a different structural formula. They would look different, but their chemical formula would be the same, and that's what comes from isomers. And you'll get to look at isomers later on, so you'll get more example of practice of that. So this is just a short lesson, mostly spent looking at cycloalkanes, which have the same general formula as alkenes, CnH2n. We saw that the smallest number of carbons that you needed to have in order to form a cycloalkane was 3, which means that the first cycloalkane is cyclopropane. We also looked at some of the properties of hydrocarbons. We learned that hydrocarbons were insoluble. We also learned to tell a saturated hydrocarbon from an unsaturated hydrocarbon, and that a saturated hydrocarbon only contains single bonds, whereas an unsaturated hydrocarbon can contain a double bond. And then finally, we looked at isomers. And isomers are compounds with the same structural formula, but a different arrangement of the atoms. So next time we'll learn more about the different chemistry of some hydrocarbons.